Hello folks, this is Tom from anti-proton.com and I'm here with some updates of sorts for you. I'm sitting here holding my camera as usual, so it's not doing a very good job. I wanted to bring you up to date on my scintillation tests. This is where I'm testing water to see what's in it, like rainwater for example. Is there radiation fallout from Fukushima, etc., that sort of thing. Also, a couple more updates for you. I do a really bad job of holding the camera. I usually have it on a tripod, but not today. So I apologize for being terrible about not holding it for you. For starters, lead. Let me show you what I have here. I've ordered lead off the interweb. Let's see here. I've ordered blocks of lead that are about 3 inches long. This is not quite to scale, but about 3 inches long. It's 6. Well, I'll tell you in a minute. That's 3 inches long by 1.5 inches wide by 0.75 inches tall. I ordered a bunch of them. For you people in Europe who don't go by inches, that's 7.62 centimeters by 3.81 centimeters by 1.9 centimeters. Hopefully that helps. I go by inches, but you know, whatever. When I'm doing science, of course, I go by centimeters and stuff. I don't use metric, I use the international system, which is effectively metric. Anyway, with lead, my calculations for the stopping power of this for average gamma ray, and this is an average stopping power. Keep in mind the stopping power also has something to do with the amount of energy, so this is an approximation. Some of you may recognize this formula. It's actually the decay formula. It's been written differently, and I'm using distance as opposed to time, but you know, what the hell. Math is math. You can use it however you want. And I end up with 1.5 inches width, stopping 92.57 rounded percent of my background up to 1 MeV energy. I hope that's true. Now let me tell you why that's important. When you have samples like this guy right here, this is a sample of water, rainwater, one of my random samples. I have lots and lots. These are both from the same lot. That's why they're not identified specially, because they will go back into a container and they're all from one particular day. I have rainwater collection buckets. See, this is from the 15th, that's yesterday. There it is, rainwater collection bucket. I'm collecting rainwater like crazy so that I can examine it and see what's inside of it. It's raining right now where I am outside of my apartment, and I'm not getting anything on my Geiger counters. They're ticking, but not very much. So, you know, whatever. I'm not getting thousands of counts I never have. I don't know what I must be doing wrong. But anyway, to give you an idea, I have run some analysis with rainwater. Let's show you here. I'm not going to go into too much depth because, well, for two reasons. A, I'm using this camera, and this camera is pretty terrible for showing you the screen. You know, I usually like to show you the actual screen with screen grabber software, and I'm going to get some better software for that. As you notice, I'm calculating from 1 million electron volts down to 1 kilo electron volt, so about 1,000 kiloelectron volt spectrum here, and you get little pulses of things right here, little pulses. This guy right here, these two right here, are probably just backscatter X-rays and such. There's a few things down here which could be interesting. We'll find out later on what these are. My technique that I use to reveal this, since I don't have any lead right this moment to shield my unit, is I took a background, that's a steady background, and then I took or let me open this up again. Water. There we go. I took a rain sample and I stripped the background out of the rain sample and ended up with what you just saw there. See? That is background. That is rain. Background, rain. Background, rain. And that's 4,000 seconds of background versus 1,000 seconds of rain. So that's why they look a little different, but this, given a few 3,000 more seconds, would have probably looked about like this. See? What I'm trying to get to is that I don't see anything in my rainwater, but once I've gotten the lead, I'll stack it around the scintillator. As you can see, I have a lead jacket. This is a foil and lead jacket around it right now, and it's nice and all. This foil and lead jacket's a little ghetto, but it's nice, and it stops some of the background, but it's not enough, and I need to stop a lot more. Now, as you can see, the scintillator, the crystal is on the very end of it right there. Beautiful, beautiful, beautiful scintillator. Alright, beautiful scintillator. The crystal is this little piece right there. And what I'm doing is, let me put this down for a minute. Putting the crystal down very, 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 very carefully. These are actually more robust than I give it credit for, but you know me, I'm paranoid. I use this, oh god, that's heavy. I use this thing right here. This is a freaking tub of lead. This is a giant lead donut. It's heavy as hell too. This thing's like 20 pounds or something. Good god, that's heavy actually. Anyway, this right here sits right around the crystal and shields it with an inch of lead on all sides. And as useful as that is, and as effective as that seems to be, I'm getting interference still. What I'm getting the interference from, I'm pretty sure because I've done some specific testing to see, is I'm getting it from coming straight up from the bottom. My table, for example, is probably just, wood has a little bit of radioactivity to it, just a drop. It's the elements that the plant had in it, the tree. I'm getting some from around the sides here, and I'm getting some from the top. So I've ordered 4 foot by 1 foot sheets of 3mm thick lead shielding. I'm going to wrap those around the top here, all the way up to the top. So only absolute direct line of rays like this will be able to get in. There's not much I can do about the top here because these power things are here, and I don't want to cross them with metal. It would, blow the scintillator to hell. Although if I still have any troubles, I could put some lead on my ceiling, I guess. Anyway, once this is jacketed, and I know this is pretty good, then I'm going to take the ingots, and these are little ingots. They're shaped kind of like this water thing, but upside down. And I'm going to stack them here, and I'm going to stack them here, and I'm going to stack them in the front, and I'm going to stack them behind. Then I'm going to put up a half-inch belt of lead underneath this thing too, maybe a full inch. The result of doing all of this is to isolate this thing, and if it's not enough, I'll order more lead, and I'll order more, and more, and more, and more, and more, and more until I blocked out my background. I'll also use some aluminum here and there too to help with beta. When I'm done with this should be incredibly quiet, so when I run one of these, I'll get very little, almost none of this. To give you an example, here's what happens when you run a background with and without shielding. Background test, here we go. Alright, here's what you get with no shields. This is a 60-second test. Let me smooth the data. 60 seconds of background, you get all this crap in just the very first 60 freaking seconds. It's terrible. Now, if I shield the hell out of it, full absolute shield, let's see, with a powerful shield, if it'll load, let me smooth the data. There. Here you go, there's nothing over here. Here you go with all the shielding I put up. Here's without it. So this is without this. With it, oh sorry, this is without it, this is with it. I mean, look at the difference. So when I stack actual bars of lead around this damn thing, I think I'm going to get a hell of a lot better view. And that way, when you get little tiny things down here at the bottom that are ticking, they'll be whatever trace elements I'm looking for, most likely, so long as they emit gamma by one means or another. So hopefully we can make a little bit of progress with that. Now, as fun as all that is, I wanted to show you guys something else, something perhaps neater. This. Zoom, 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 zoom. Okay, my zoom sucks. Don't even know why they put it on the camera. Let's pick it up and put it where you can see it. These little flakes. And you're saying to yourself, okay, Tom, those are neat. What the hell are they? What are these tiny little flakes that seem completely useless? What are they? Well, I don't know. Let's find out. Let's put the Geiger counter where you can see it. As you can see, we're at 45, 50 counts per minute. Yeah. That's not a rain sample. Again, I would like to point out the silliness of claiming that rain is putting out 20 or 30,000 counts per minute. This is a vial of uranium with actual uranium ore. With actual uranium ore. I still can't get 20,000 counts a minute. I have 2,000. I get up to 6,000 something with these. Here, if I put the little container right here. Oops. And then I stick. There we go. Yeah, that's not really accurate, is it? Look at that. It'll get up to 6, depending on how you angle it. Anyway, this is the this is a little bit of uranium, and it's from the famous oh, what's the mine called? God, I'm so terrible with names. Let me pause for a second. Oh yes, Daybreak Mine. That's it. It's the Daybreak Mine in I think it's Washington. I've got to get better with my names and things. Anyway, this is called autunite. Beautiful, beautiful autunite. And I'll show you why it's beautiful in just a minute. But before I show you why it's beautiful, because my God, it's beautiful, let me show you what it looks like under a spectrum. Hold on a second. Let me get my spectrum. Here you go. Here's the first 512 kiloelectron volts. As you can see that, I mean, I'm not sure if these are exactly accurate. I think these are accurate, but I'm still kind of new at this. Actinium-228, thorium-227, thorium-227, uranium-235. Yeah, uranium-235, radium-220, radium-226, radon-222, uranium-235. I really got to get better at the way I do these things so you can see it better. Radium-223. That right there is actually Ra. Might be radon. Huh. Well, anyway, Peractinum, U-235, thorium again. Yeah, all the usual bootleg snacks whenever you get a chunky uranium. Awesome stuff. Let's see if I have anything else here to... Here it is up close. It's the first 36 kiloelectron volts and all the little things that show up in it. Uranium-235, Peractinum, I think it's radon, Ra, damn it. The difference between Ra and Rn. Radon is Rn, radium is Ra, I believe, off the top of my head. Why do I always mess that up? So anyway, let me show you why this is neat. Hold on. Here, let me show you what it looks like under a black light. Alrighty, here you go. Black light. Oh God, that's bright. And look at that autunite. Oh my God, it glows. The autunite glows like a champ. Look at that. Wow. Now let's take it, oops, put it on my little Geiger counter here because it sounds so much better in this Geiger counter. Oops. This Geiger counter just can't put it out when it comes to ticks, but my God, it's bright. Yeah, it's bright, and this Geiger counter sounds so much better. Gives my here it is. Gives my tritium a run for the money. That's for sure. Beautiful stuff. Beautiful stuff. But alrighty, folks. Well, this has been Tom from anti-proton.com. Stuff doesn't really put out too much unless you get too close to it. And oh yeah, this weekend I'm going to post a couple more videos, including uranium. I'm getting another piece, so I have 2 pieces of uranium, not counting my depression glass pieces as well. We'll see if we can huck it in the old scintillator here. Its name is Nikonami. Nikonami. Yes, we'll see what Nikonami thinks. My scintillator. Oh, and also I'm hoping by Thanksgiving, and that's a United States holiday if you happen to be from abroad. So that would be on the, what the hell is it, the 24th or something like that? Next week, approximately this time next week, I hope to have all my lead set up, and we're going to test rainwater, and we're going to see what's in it. I don't even get 20,000 counts per minute from a scintillator, which gets thousands of counts a minute from this. So we're going to see what we get in our rain. This has been Tom from anti-proton.com, and bye-bye.